Hi and welcome to Gaffy's Grinds. This is video 2 of our series on trends of the periodic table. Before we begin, a usual reminder that it's important now if you try and eliminate any distractions, and that means your mobile phone, let's at least put it on silent, better put it on do not disturb, and even better still, put it somewhere else out of your room because it's the number one distraction that we all have in our lives. And if we can get rid of that distraction, we have a better chance of learning. And most importantly, make sure that we are doing any of the tasks that I asked you to do in the video. So I'm going to be asking you to do questions, practice. I'm going to be asking you to take down different things. It's really important that you do things exactly the way I ask you to. And if you manage to do that, then you're going to learn a lot of stuff. All right, we're going to begin today's video by doing a quick bit of revision. So I've got a couple of questions for you guys to practice. And this is all stuff that you should already be able to do. Okay, so I'm going to ask you now in wherever you're going to do your questions. So get a pen and paper, and I want you to pause the video and do these questions. Okay, so you should only be listening to my voice if you have paused the video and you have had a go at those. I'm presuming you're not jumping straight into chemistry for the very first time in this video. So this stuff is pretty basic stuff, and I'm hoping it's something that you guys can all do already. The first thing is to draw a Bohr atom of lithium. I hope that was clear. If not, pause the video and do it now. Okay, so draw a Bohr atom of lithium. So lithium looks like this. We've got lithium in the nucleus. We've got lithium and our electrons. We've got 2 in the first shell, and lithium has 3 electrons altogether because it's got an atomic number of 3. It's got 1 in a second shell like that. So 2 electrons in the first energy level and 1 electron in the second energy level, just like that. Number 2 says lithium is a metal. It's a metal atom that loses electrons in bonding to become an ion. Use a diagram to illustrate this process. Well, what we've drawn here is a lithium atom, and when it undergoes bonding, it is going to lose that electron. Now, it doesn't just disappear. Electrons can't just vanish. They're going to somewhere else. So they're going to another atom that's good at removing electrons from lithium. Now, you may have decided to illustrate that. You may have decided to put in something like a chlorine atom or a fluorine atom. So if we go with a fluorine, it's just easier to draw. We have fluorine has 2 electrons in the first shell, and it's got 7 of its own electrons in the second shell like this. And it's got 1 in the third shell. And actually, you know what? That's not a good idea. I should draw the electrons as a different shape so that I know which ones are which. So I'm going to say fluorines are dots. So like this, that would be better. So 2 in the first shell, and 1, 2, 3, 4, 5. It's got 6, 7 of its own like that, because fluorine has 9 electrons altogether. Its atomic number is 9. It's got 9 electrons altogether, and it would like to have 8 in the second shell. So when it takes its 1 from lithium, it has its full outer shell. Now what's happened to lithium? So we should show lithium becoming an ion. So what's left of lithium is now just 2 electrons in that first shell. So we say that lithium has become a plus ion, and this fluorine has become a minus ion. Yeah, I'm not going to draw all the electrons. I've already done it above. Okay, just use this one. Okay, like that. No, minus. So we've got Li plus and we've got F minus. And of course, these two then would attract each other. And that attraction is called an ionic bond. Now, that's not what's important here, though. What I was most interested in is knowing this process. So I wanted you to show lithium is a metal. Use a diagram to illustrate the process where lithium loses a metal and becomes an ion. So that's what we have done. Lithium is a metal. It becomes a positive ion by losing an electron. Now, if you just drew the arrow, the red arrow, and you didn't show an atom taking it, that would be fine as well, because that's all I've asked you to do here. The next one says, write the SPD electronic configuration of aluminium and chlorine. So let's start with aluminium. Aluminium, if I just grab my periodic table, I'll just have to pause the video and get it. Aluminium has an atomic number of 13. That means it's got 13 electrons. So aluminium has 13 electrons. That means it has an electronic configuration of, goes like this. Well, we start with 1s. The first energy level is number 1, and we're in the S sublevel, and it can hold 2 electrons. So 1s2. That's 2 electrons accounted for. If you have no idea what I'm doing, by the way, it's a good idea to go back and watch the video where I did electronic configurations. So I'm presuming that you've been learning all the time along with me and that you know what I'm doing. If you don't have any idea what I'm doing here, then it's a good idea to go back and watch how you do that. So we've got 1s2. Then that energy level is full. We're into the second energy level. We've got 2s2. That's 4 electrons. And in the second energy level, we've got p sublevel as well, 2p6. We've now accounted for 2, 4, 6. We've got 10 electrons accounted for here. We've got 2 here, we've got 2 here, and we've got 6 here. That's 10 electrons accounted for. We need to account for 3 more. So they will go into the third energy level, 3s1 and 3s2 and 3p1. So that would be aluminium. So that's what you should have written. 1s2, 2s2, 2p6, 3s2, 3p1. Well done if you did that. The other one we were asked to do was chlorine, Cl. Chlorine has 17 electrons. 17 electrons. So it will have an electronic configuration, 1s2, 2s2, 2p6, that's 10, 3s2, that's 12, and I need 5 more. So they will go into 3p5 like that. So that's how we would do that. So that was just a quick bit of revision that leads a little bit onto what we're doing today. Now there's this thing called ionization energy. We're going to take a look at what that means. Well, we recognize a word in here, I'm hoping. Recognize the word ion. Okay, and obviously, hopefully, we understand what energy is at this stage. Energy is basically what makes stuff happen. So we've previously learned that atoms can lose electrons. So nothing new there, and we've just showed that in question 2 here. Lithium losing an electron. When atoms lose electrons, they become ions. That's what we call them. When they lose electrons and they become charged, we call them ions. So let me just show this, what we've drawn over here. The lithium becoming a lithium ion. We're going to show this. We can show this using an equation like this. Okay, so we've got Li. This is a lithium atom. Okay, so this is a lithium atom. Now, it can lose an electron to become Li plus, like this. This is what we call a mono. Mono means one. Positive, because it's got one positive charge. A mono positive ion. Some of you eagle-eyed people out there might know that this is what we call a cation. Cations are positively charged ions. Cation. But mono positive ion because we have one positive charge. Plus an electron, because the electron is also produced. So in this particular type of reaction, we have a lithium atom becoming a lithium ion and a free electron. So this is a free electron. Now, of course, it doesn't just disappear. It is going to go somewhere. It's going to attach itself to another atom usually. Okay, so it doesn't just disappear. We call this process ionization. So when we take an atom, we turn it into an ion, it's called ionization. And for this particular equation here, what we have shown is the first ionization. The first ionization. Why is it the first ionization? Well, it's the first ionization because this was an atom. And atoms are neutrally charged. They have not lost or gained any electrons yet. So this is the first time it's losing an electron. So it's called the first ionization. And it's represented using an equation like this. I'm going to do another one of these now. We are going to do first ionization equation for something like sodium. Let's take sodium as an example. Okay, so sodium has the symbol Na. And we are going to show write an equation to show the first ionization of sodium. So sodium loses an electron. This is a sodium atom and it's losing an electron. When it loses an electron, it becomes Na+. It's lost one minus or negative electron, remember, plus an electron because it's losing that one electron. So remember, we're not adding together these things. This has essentially given this out. So that's why this has given this out and become Na plus and the electron has gone somewhere else. So we have to keep track of the electron. That's why we're saying plus E minus, because it's there, but it's gone somewhere else now. So Na plus E minus. So that is an equation for the first ionization of sodium. I want you to try these three now. Okay, so you're going to do calcium. You're going to do boron. And you're going to do chlorine. So what I want you to do is I want you to pause the video now and write down an equation for the first ionization of each of those three, please. Do that now, pause the video. Okay, so you should only be watching the video if you have paused and tried to write an equation for each of these things. So this is what you should have. For the calcium, we begin with a calcium atom, Ca, and it's going to become a calcium ion, Ca plus, and it's a monopositive ion, so it's just +1, and we've lost one electron, so plus an electron has been lost. Boron has a capital B, so this is a boron atom, is becoming a boron plus atom, a monopositive boron, and an electron is also produced, and it's given off to another atom. Chlorine has the symbol Cl, and this is a chlorine atom, and it's becoming Cl plus, a monopositive chlorine, plus an electron, like that. Okay, so hopefully you got those right. They're just the same as the ones I did, and that's what this channel is all about, is giving you lots of chance to practice in small steps. And again, that's what I believe makes our channel different from lots of other channels that don't give you that opportunity. Now, following the first ionization, which I'm going to write here for magnesium, I'm just going to do one more. We've got magnesium. Magnesium can lose one electron to become Mg plus that one electron is also produced. Now, following first ionization, well, there's nothing to stop this monopositive ion, monopositive magnesium ion, from losing a second electron. Now, if you've got the correct conditions for this, okay, and in the next video, we're going to talk about the types of conditions that's needed for this to happen. But if we were to take this Mg plus ion, this monopositive ion, there's absolutely nothing stopping it from losing a second electron and becoming Mg2 plus another electron, like that. Okay, this now is what we would call a di, meaning two di-positive ion. So that would be an ion or an atom with two positive charges because it's lost two electrons. So this would be an equation for what we call the second ionization. The second ionization. So this one here shows a second ionization. And I can recognize that as a second ionization because I'm starting with a monopositive ion. It's already lost one electron and now it's losing a second one. So I can recognize this as a second ionization, whereas I recognize this one as a first ionization because I'm starting with an atom and it hasn't already lost an electron. So this is first ionization. Now again, under the right conditions, this can happen again and again and again. I can get a second, I can get a third ionization, fourth ionization, fifth ionization, if the conditions are correct. Now, what do I mean by conditions? Well, we're going to see it's all to do with energy. We're going to see this later on, that each time you remove an electron, it requires energy. And if you keep giving inputs of energy, then you can keep removing electrons. All right, it's time to do some more practice now. All right, so we're gonna take a real life example here, and we're gonna write the first ionization, an equation to show the first ionization of aluminium. Okay, so we have aluminium, Al. I'm starting with aluminium, and I want to show the first ionization. Well, that means it's an aluminium atom, and it's becoming a monopositive aluminium ion, and I'm losing an electron like this. Right, what I want you to do now is I'm going to pause. I want you to pause the video, and I want you to write down the second ionization, an equation to show the second ionization for this, please. Okay, so you should only be watching the video if you have written an equation for the second ionization of aluminium. You should have had this. You're starting with a monopositive ion. It's already lost one, so it's Al plus. And you're losing a second electron to become a dipositive ion. And there's that second electron, like that. That would be correct. Right, what I want you to do is I want you to pause the video, and I want you to write the second ionization of cesium. So you're going to need to go to your periodic table, find the symbol for cesium, and write the second ionization energy for that, please. Do that now, please. Okay, this is what you should have. Cs is the symbol for cesium, and it's the second ionization energy, so it's already monopositive. It's already lost one electron. And I am showing it losing a second one. So this is going to become Cs 2 plus an electron, like that. All right. Now, what about if we do the third ionization? Let's write an equation for the third ionization of, say, oxygen. Well, that would be, if I'm writing the third ionization, that means it's already lost 2 electrons. So it's already going to be O2 plus. And it's losing a third electron. So this is going to be O3 plus that third electron. But before we go any further, we're just going to classify these. Okay. So I'm going to get you to pause the video. And beside each of these, I want you to write down, are they showing first ionization, second ionization, third ionization, etc. Pause the video and do that now. Okay, so you should have said this is a first. This here is showing a second. This is showing a second, and I know this because of what I'm starting with. I'm starting with a monopositive ion, so this is losing its second. And this is showing the third ionization. Well done if you got those right. Super stuff. One more little challenge for you. I want you to show me the fourth ionization of chlorine. So write an equation for the fourth ionization of chlorine. Do that now, please. Pause the video. Okay, so this is what you should have. You should have Cl, and if it's the fourth ionization, it's already lost 3 electrons. So it's Cl plus 3. So if you got that bit right, the rest is easy. Well done. Okay. If you didn't get that right, pause the video and finish it off now. Okay, so I'm hoping that you said it's going to become Cl plus 4 and an electron. Like that. Good job. The key thing, I suppose, is remember every time you only lose 1 electron. All right, we're only using 1 electron at a time. I've got some more questions for you guys to practice. Practice makes permanent is what I always say. Okay, so what I want you to do is pause the video and have a go at these, please, right now. Okay, so you should only be watching the video and listening to my voice if you have answered these questions. First of all, what is ionization? Well, ionization is when an atom, so ionization is when an atom loses an electron to become an ion. To become an ion. Okay, so when an atom loses an electron to become an ion, that is ionization. Or when a monopositive ion loses an electron to become a dipositive ion, that could also be a definition. All right. Depends what you're starting with. When an atom loses an electron to become an ion, we say its ionization has happened. True or false, the equation shows the first ionization of magnesium. So it's false. Okay, so it's false. Now, I forgot to actually change them signs. I was supposed to change that to mg and mg, like that. So you might have thought it was false because it was x's and not mg's. Now what do you think? So pause the video and see, do you still think it's false? Okay, it is false. Okay, it's definitely false. And the reason for this, how do you know? Well, it's because it's not the first ionization. It asks you, does it show the first ionization? Now we're starting with a monopositive ion. So this can't be the first ionization. Okay, so how do you know? We know because we start with a monopositive ion. This monopositive ion has already lost an electron. So it has already lost one electron. So it can't be the first ionization. Write an equation for the first ionization of fluorine. This is what you should have. F, it's an atom, it's the first ionization. We start with an atom, become F plus an electron. Well done, you got that right. Write an equation to show the fifth ionization of nitrogen. So we're going to have N plus 4, because it's already lost 4, and we're showing the fifth, N plus 5 plus an electron. Again, well done. If you're getting those right, then you have a really, really good grasp of this. Okay, now let's look at why, or let's look at a little bit more as to well, a little bit more detail. It's going to get a little bit more complicated now, but again, it's nothing too major. Now, the first thing to note is that we've previously noted that electrons stay in orbit due to their attraction to the positive nucleus. So if I was to take, say, an atom of sodium, Na, and sodium has two electrons in the first shell. It's got 8 electrons in the second shell, like this. 1, 2, 3, 4, 5, 6, 7, 8. And it's got 1 electron in the third shell. And the reason why this electron out here, or why any of the electrons stay attached to the atom, is because they are attracted to the positive nucleus. We call this here the nuclear charge. We learned this in a previous video, the nuclear charge. It's because all the protons are in the nucleus. We've got protons and neutrons in the nucleus. The neutrons are neutrally charged and the protons are positively charged, and that makes that area in the center of the atom very positive. So the electrons are negatively charged and they are attracted to the positive nucleus. So we call this the nuclear charge. It's what keeps electrons orbiting and stops them from just heading off wherever they want. They're not allowed to just head off wherever they want. They're limited in this, how far away from the nucleus they can be due to the nuclear charge, okay? Now, obviously, if you want to remove an electron and whip it away, completely remove it, you have to overcome this force. You have to overcome the nuclear charge. Now, to do this, we're going to require what we call an energy input. So energy is going to have to be put in. Energy in. So energy in will help you to remove the electron. So you'll give the electron enough energy that it can actually leave its orbit and detach from the atom altogether. So it's going to actually break the connection that it's got with the atom. You have to overcome the nuclear charge. Now, as a result, any ionization, all these that we've shown above, are all losing electrons. So all of these are going to require an energy input to overcome that force of attraction between the electrons and the nucleus. Now, obviously, this electron here is the one, if we've got this electron here, sorry, I'm just going to highlight again, the one that's got the circle around it, this one here. This is the furthest electron away from the nucleus, and therefore it's the one that's least tightly attracted or least tightly held by the nuclear charge because it's furthest away. Of course, that we know its atomic radius is big. We learned that in the previous video. So the atomic radius is that big because that's where the outer electron is, and it's the outer electrons that are going to be at least attracted to the nucleus because they're far away. So these are the most loosely attached, and these will obviously be the ones that get lost first. Now, this energy in, we call the amount of energy in that we need to cause ionization. We call this the first ionization energy. So it's the energy required to completely remove this electron from the atom. Now, generally, we don't tend to talk about just single atoms. We tend to refer to, when we're talking about chemistry, we're counting things in moles usually, okay? So we're talking about mole of atoms at a time. So if we say the minimum energy required, the minimum energy required to completely remove the most loosely bound, because we're always removing the most loosely attached or the most loosely bound electrons from 1 mole of, and we're usually doing this with atoms that are gases. So if we wanted to actually measure this quantity, we would actually have to vaporize the sample first, and then we would have to ionize them and measure the energy it took to remove the loosest electron. So usually it's only possible to ionize things when we've turned them into a vapor. You can't actually take electrons off them until they're gas, in their gas form. So that's why this word here is appearing in the definition. Gaseous. It just means they have to be in the gas form. So let's just take stock of what I've written there and reread it. So it's the minimum energy required to completely remove the most loosely bound electrons from 1 mole of gaseous atoms. This is what we refer to as the first ionization energy. And it is a definition that we need to learn. But like I said, I hope I've explained really good or really well what it actually is, because I don't just want to ask you to just learn something for the sake of it. I want you to understand it too. Now, why is it first ionization energy? First ionization energy. Well, we're talking about gaseous atoms. So if we're beginning with atoms, they haven't lost any electrons yet. So it's the first ionization energy. Now, if I wanted to write a definition for the second ionization energy, I could easily do that by just changing a couple of these words. I would then say it's the minimum energy required. Actually, do you know what? What would you say? I want you to speak your answer out to the screen now. So actually practice saying this. So speak your answer out to the screen on 3 now. 1, 2, 3. Okay, so I'm hoping that you said something like this, that the second ionization energy would be the minimum energy required to completely remove the most loosely bound electrons. You're still going to remove the next most loosely bound electron from 1 mole of gaseous monopositive ions. That would be how you would describe second ionization energy. So make sure you've used the keywords monopositive ion. That would be the second ionization energy. The third ionization energy, again, you would say the same thing, but you would replace it with, at the end, with dipositive ions. Dipositive ions, then that would be the third ionization energy. All right. Good. Okay, I think we are ready to do some more practice. Just that is a definition, so it's a good idea to take it down, box it, highlight it, make sure that you guys actually understand it properly. All right, so make sure you take a note of it and you're going to actually learn that. Okay, I know my students, I get them to learn using some kind of flashcards, learn these definitions using flashcards. They all understand them, but then you've got to put the time in practicing, recalling them to make sure you get them. So put them on a flashcard, use a Quizlet set. Quizlet is great for this, something like that. whatever way you have, but you need to be practicing, not just looking at them. You need to actually practice either writing them down or saying them or typing them or whatever. Okay, another question for you to do now, or 2 questions. What I want you to do is pause the video and answer the questions, please. Okay, so you should only be listening to my voice if you have had a go at doing question 1 and 2 there. So the diagram shows an atom of sodium. 2 electrons are labeled A and B. Which electron will be lost first during ionization? I'm hoping that you said B. So B. And how do you know? So we didn't just say we didn't just say B, we said how do we know? Well, I'm hoping that you said B is the most loosely attached, or the most loosely bound. Is the most loosely bound electron. Why? Well, because it's in the outer shell, or it's furthest away from the nuclear charge. Most loosely bound electron because it is furthest away from the nuclear charge. Furthest away from the nuclear charge. So A is closer to the nucleus than B, which means that A is held tighter to the atom than B, so it's easier to remove B. So when you apply a certain amount of energy, B is going to hop off, and A is not going to hop off until you add more energy. Okay, it's that simple. All right, next thing I want you to do is I have, this is the last thing now in this video. What I want you to do is I want you to practice writing. I want you to write out this paragraph. So you're practicing some key words. This is really good for improving your scientific writing. It's really good for helping you really process and understand what we've learned today. So I want you to write out a paragraph, but fill in the blanks with the key words from today's lesson. Okay, so do that now, please. Okay, so you should only listen to my voice if you have that written out and you're confident about what you've put into those blanks. The keywords are coming up now, so make sure that you correct them and change any of them that you got wrong. So as you can see, the keywords are highlighted. Okay. Now, I'm hoping that was pretty straightforward. I can't really see where you might have gone wrong. Maybe this one here, the dye-positive ion, might have been the trickiest one there, is what I'm guessing. But I can't really see how that could have gone too badly wrong. All right, so this is ionization energy. It's a second thing we think about on the periodic table. And in our next video, we're going to look at the patterns in first ionization as we look around the table. So how does it change for the different elements? And is there any pattern or reason why the trends that we see or the patterns that we see might exist? So that's what we'll be covering in the next video, and I look forward to seeing it. If you found this video helpful, guys, give it a like, and that just helps other students in Leaving Cert Chemistry or even other courses from other countries that need to know about this stuff, and that it just helps more people find the video. So it'll be really helpful if you could, and I'll see you in the next video.